reduce the token of the system prompt. We try to cache the system prompt. We try to do semantic search. We try to do embedding of the message the user has given. We try to take the recent one. We try to do the semantic search of the messages, and then these all will keep on improving. Then there is a most important part is a metadata filtering. If you think there are millions of documents, or let's say thousands of documents uploaded by a business, right? And that business is exporting an AI agent for, let's say, their customers, and they are trying to search their own single policy from their chat document. And once they do the search, what we do right now, we put all the documents, we will do the indexing, right? And even we create namespaces. Let's say the first one technique is the compression of the prompts. Let's say you write always be helpful, always be friendly and concise and answer politely. But rather than this, you can write be concise, accurate, and professional. This would be the best possible prompt, and it will impact around 30 to 40, 50% about your token usage. Correct? Instead of writing a paragraph, you can use XML or JSON. That is a second way of compressing the prompt and making it more better. And it should look structured also. And it works better with Claude or OpenAI or Gemini. So you say the role is cloud architect, and then these are the different set of rules, and the efficiency becomes stronger, and also the token usage become less. Then the third part of compressing prompt is doing compression of the conversation. So for example, instead of sending all the turns like the user messages, the agent replies, again the user message and the agent replies, you can generate the conversation summary of whatever has communicated and then send the summary rather than sending the complete request or complete set of input and output of users and agents. So you send just the conversation one. Now the second one is context pruning. What happens in context pruning? Let's say a user has communicated with your system for, let's say, 30 days, right? Yesterday he talked about how to deploy ACS. 2 days ago he talked about what is the AWS pricing. Right now he's talking about deploy Lambda. So you don't have to go and pull all the records and then send it to your LLM system. Rather, what you do, you create embeddings for each and every message that has been sent by the user and store it into the vector database. When user asks that kind of question, then first do the query inside the embedding and try to figure out if there is a question and answer that has been happened previously. Pull that relevant responses and try to generate the response. This would take lesser number of tokens for you to send it to LLM call, because in every call, whether you do tool call, whether you do memory call, whether you do anything with LLM, every time you have to use tokens, right? The second option is recency. So let's say a person or a customer is talking to your system for almost 30 days, or let's say a month or 2 months or 3 months. Then rather than pulling all those previous data, you should try to pull the recent messages, let's say 7 days messages. And then if you try to combine these together, that becomes a very highly production hybrid system where you do embedding semantic search also and you do recency also, right? This is called context pruning, correct? And this will highly improve your complete system and also the tokens. We talk about the third one. Then what happens, let's say user has stored around 300 memory to your system, to your dashboard and app, and let's say user works at, for example, user works at Amazon, lives in London, uses AWS, blah blah blah, and but he tries to ask deploy Lambda. So you don't have to send all these data to the LLM and generate the answer. What you can do, you can do cosine similarity of what he is asking and what different nearest neighbors and embeddings that you have in your vector database, and then find top 3, let's say a top 5, right? You can also build a ranker, ranker agent that will rank the responses that is coming from embedding and then give to the agent, and then it will become more and more efficient, right, for the customers. And also you don't have to send all the 300, you have to just send the nearest available. So you see, this is the way the similarity is being measured. We use cosine similarity between vectors, right? Like a query vector, that is a deploy Lambda, that user is querying it, and the memory vector, that is a use AWS Lambda, use AWS embedding. Both of them are stored together inside the vector embedding, and if both of them cosine similarities matches, then this will be returned to the agent. right? And then your token usage will drastically go down. Rather than using all the 300, you have to use a lesser one. Then happens the prompt caching one. This is the most important. Let's say what developers miss here is when you send two type of prompt basically in every API call. You do send system prompt and you do send user prompt. So you have to make sure that in the system prompt it always remains identical. It never changes. And for the user prompt, you can add all the extra details about the user details, their name, their other different set of configurations you can add. But system prompt has to be identical. So though these two models like OpenAI and Anthropic, they support the caching of the identical system prompts. So they say that automatic prompt caching for identical prefixes, right? Cache tokens are built at a lower rate. Whatever system prompt cache token are there, they OpenAI build it at different rate, and also works best when system prompt and instruction are stable. So that's what I'm saying. Try to use the structured system prompt. Try to use very minimal tokens in the prompt, like very less characters in the prompt. Try to be very specific about the prompt, and try to be send the variables inside the user prompt rather than the system prompt. So this will help in kind of, let's say, first request comes in, this goes and OpenAI will respond with the cache request, and the second request, subsequent request will go. Then only the user prompt token will be charged. It will be also faster because OpenAI will be caching it. Correct. So the what is the key takeaway? Your app does not manually manage the model's internal cache, right? Because you are not managing it. You design prompt to maximize cache hits, right? It will be managed by Anthropic and OpenAI or Gemini. No, the provider handles the optimization behind the scene. Now the fifth part is model. So think about when you get a job in your company, you try to give it to the person that can solve it. Like let's say a very complex problem comes in, you give it to senior member. Yeah, a very simple problem comes in, you give it to a, let's say, a developer or maybe to intern. So you categorize whom to give this problem and how to utilize your time and money better. So similar ways model and model routing works here. Let's say you just want to do a planning and you want to reply a simple message, or you want to select which models or which router or which API or tools to use. So why use an OpenAI Opus or OpenAI 5.6 model or Opus 4.8 model? We can use a very cheap model than this. Like we can use OpenAI GPT-4 Mini, right, which costs less. So so whenever you try to build an agentic system, we have to make sure that whenever it's needed less type of, like you can think of it as how the complexity of the problem would be of any agent handling it, right? Let's say like is it for Claude Sonnet can handle it? Is this kind of query Claude Sonnet can handle it? Then route all this kind of requests to Claude Sonnet. If this kind of problem Opus can handle, then route Opus to Opus. Then it will make your model system, the whole agentic system, efficient also, and also cost efficient. Correct. So these are the example. Like model routing is really important. Though there is another one, the parallel tool calling. So let's say that you try to build a multi-agentic framework, and every agent has multiple tool calls that they do. Right now what happens is you do tool call 1, then tool call 2, and then tool call 3. This will increase the latency inside the system, because every API or basically tools will have to return the data after some latency period. But what if you do parallel tool calling and then return the data to the model? This will help your complete system be very efficient in terms of latency, right? So benefit is for parallel tool calling is it becomes much lower in latency, better user experiences, and higher throughput, and scales better. Because let's say you can use Lambda and SQS and SNS infrastructure, like you say fan out architecture, and that runs parallelly, grab the data and just send it to the LLM you need, right? The next one is streaming. So what happens is most of the time whenever we do the API merging with these OpenAIs and LLMs and Gemini and Anthropic, we try to do one-time request. Like we send the data, and once the LLM fully returns the data, then we get it. But that is not efficient, and that is not also good for user. So we should try to do the streaming that they allow. So So this is how the streaming work. Like as soon as because that is what GPT's work is. Like it has to generate the next word from your given input, correct? So we should try to use the streaming part, right? It will make your UI look better. It will make your system look better. It will make it more efficient, and user may try to judge the responses before everything is getting completed, right? The other one is dynamic context window. Here is this is really important. So if you see, the problem is many system always send the maximum context window up to 120k tokens, right? A better approach is how much context does this request actually need? Like for example, if I say the simple greeting is user says hi there, needed context last 2-3 messages. So that is 5 tokens, 500 tokens for example, because I'm just sending hi. So it has to understand what user previously communicated with the system, and then accordingly it has to respond. The second point of problem, for example, coding question, right? Why is this function returning undefined? So recent code snippet plus relevant memory. Think about another one, like let's say you have added a complete code to cursor, and there would be, let's say, 500 of files, and you just tell to cursor that your auth login is not working. So what cursor usually used to do earlier, it used to go and search all the files, but now as their system is evolving, what they do is they index all the files, right, and only query to the files that is needed to for that answer, correct? And that is what context window is like. So uh, like for example, if you look, say, refactor this report to use a new architecture, so needed context will be large amount of code plus architecture documents plus repo structure plus memory, right? This could be 60 to, for example, 60 to 1 lakh token. So and the production system dynamically assembles prompt based on the task. Right amount of context is called lower cost, lower latency, and better focus. So this way, with dynamic context window, like what kind of context is required for the user query, you can increase or means you can decrease token usage, correct? If you talk about LLM-as-a-Judge, so what you see that user sends a query like summarize yesterday AWS billing and send me to my email, right? So LLM is a judge. So first this goes to the LLM, and you build an agent that decide what to do with this request. So now it says that does this query need a large language model? So this is the decision that LLM-as-a-Judge is making. It says yes, then call large language model, and this is how the context window will occur. Can it be answered from the cache data? Yes. Then return cache response to the user, and then if needed be, it will go to the large language model. If previous answer is already sufficient, yes, return previous answer. So this way you can do it. There is a ninth one that is really important, and it has to be used in a proper cure manner, is query writing. For example, I communicate with a system, agentic system that you build every single day. Right now I come, and rather than asking a specific question, I say how much did we spend last month, correct? But we know, our system knows that where we spend money, correct? So let's say we communicate about AWS but not Azure, marketing, payroll, etc. If if we send a query directly to LLM or retriever, results will be vague and irrelevant. Think about if we can format that query, not for the user, for the LLM that we sent. So the original query was how much did we spend last month, like, and then our model, the small model, will rewrite it to how much AWS cloud spending occurred in June, right? And then it will become very close to what user previously is communicating, and from the context memory. Again, if we talk about the previous memory and context, again we'll go to the same, all the system that we talked about. We try to reduce the token of the system prompt, we try to cache the system prompt, we try to do semantic search, we try to do embedding of the message the user has given, we try to take the recent one, we try to do the semantic search of the messages, and then these all will keep on improving. Then there is a most important part is a metadata filtering. If you think, there are millions of documents, or let's say thousands of documents uploaded by a business, right? And that business is exporting an AI agent for, let's say, their customers, and they are trying to search their own single policy from their chat document. And once they do the search, what we do right now, we put all the documents, we'll do the indexing, right? And even we create namespaces. Let's say in Pinecone we do create namespaces, and all those namespaces get stored inside, let's in as a vector embedding. So when we do the search, when we try to use that embedding from our AI agentic system, then we do the query. Then again, the our messages converts into embeddings, vector embedding converts into embeddings, and then they get searched. But still, you have to search the complete vector embedding. Even for that namespace, let's say a single user namespace is there, and he specifically has 5,000 different documents in his vector embedding, but you still have to search that document. Think about what you do. You take the document and you do metadata. You create metadata for all those documents, JSON for example, and you try to label it, right? Let's say this document is for his policy one, or this document is for his salary one, something like that, for all the different documents. And then you store the metadata as a JSON format, like we used to do as a JSON in MongoDB for, let's say, aggregation or query. And then once you just do the search, you first do the metadata filtering. You apply exactly what kind of query and from which kind of document and which kind of embedding search we should apply. Rather than going for a whole lot of embeddings, we should just go for that window part of embedding, and that will make it really better. So that is the 10th metadata filtering. Now we try to understand about hybrid search. I've already like kind of told you. We try to combine basically keywords, and we try to combine semantic and metadata filtering. So just told you metadata filtering. Semantic is about trying to understand the embedding, trying to store it into the vector database, trying to do the cosine similarity, and trying to return the result. And then also the keyword search. Keyword search, you everyone know. You perform, let's say you do elastic search, you put indexes inside elastic, and you match the indexes with the vector embedding metadata. So the search happens, it goes to elastic, metadata returns 10 results. All those 10 results have vector embedding values. Those vector embedding values goes to Pinecone, let's say for example, a vector database, and that returns the embeddings, and then from the embeddings you do the search. Think about how fast and cost efficient it will be, rather than directly going into searching inside vector embeddings. Because if you compare this cost, whatever I named, like I named Elasticsearch, I named Pinecone for example, and your tokens basically. Even only OpenAI, sorry, not OpenAI, OpenSearch inside AWS Bedrock cost hell lot more than single Elasticsearch instance running for a month. Like it will cost whatever Elasticsearch will cost for a month, it will cost for a day. That is the difference between how much you can save, right? So that is 11th. The 12th is a chunk optimizations. So what happens here over here? If we look at that, what we do, we try to, if we are having a agentic business and we try to build a PDF kind of chunking for the chat support, what we do, we try to store entire PDF. Rather than that, there are like 10 different way of chunking. I have already made a video on this. There are 10-15 different ways of chunking you can apply, like there's section wise chunking, paragraph wise chunking, semantic chunking. There is AI agentic chunking, where you give the PDF to the agent, and agent will understand which kind of paragraph matching to each other. So you don't have to do a bracket of 300 characters or 500 characters. You just do what AI agent says, that these kind of chunks should be merged together, and then it will go ahead. Then there is dynamic chunking. Now this is really important. This everyone should do. And I am telling you all this from my own personal experience of all the agents that I have built in previously. Dynamic chunking is basically choose chunk size based on the content structure intent. So there is a legal contract. So for example, I have added 4 different kind of documents over here. So there is a legal contract, there is a medical records, there is source code, and there is chat. Wherever different type of businesses comes in, industry comes in, then we have to make the decision. Like for legal contract, how section by section we have to store, or para by para we have to store. We have to take, it depends upon the business. Again, I'm telling you, let's say that how you gonna make the decision. If you'll ask, then if you have to, let's say, memorize this, or you have to understand a PDF and tell to someone, how you gonna do it? You're gonna do it by para, line, or section by section, or topic by topic. Similar way, you do it for the chunking. That's it. That's a simple answer I can give to help you understand dynamic chunking. And see, like for medical records also, like why do we have to chunk one line if we can have one complete visit chunking at once, right? And this will help you a lot, because what matters is doctors will ask what happened in the previous visit, or let's say consultant asks what happens in the previous visit. Same with the source code and chat. So this way you can increase. Then there is a fourth one. I think 14th one I have already covered is about cost aware routing. Is how we can route our request to a different lesser model that costs lesser than the other model. So let's say if a simpler FAQ question is there, so then it will go to, and also the most important part I can say, this can happen very dynamically. You can decide the, like, let's say that you can create a score, model score, and you say, let's say 15%, 20%, 50%, 80%. If it comes from 0 to 15%, send it to the very lesser model. Or let's say the planner is very small, or it depends upon the business that you are in solving problem for, and then you try to send that request to different people, different LLMs. So user gets a great answer, and the router optimized for quality and cost behind the scene. They never know which model handle the request, because how they do know, and how it works. If you are trying to understand that, first of all, you have to make sure you understand the intent, right, and the complexity and Niger. Intent is basically whenever you try to write a sentence in any format, the LLM has to understand what it's trying to say, and then let's say summarize it, or let's say parameterize it. Let's say I'm trying to talk about a bank statement. Give me how much money I spent in last week of July, or for last week of June, for example. Then I said June, there is 2026, and there is last week. So last week, which date? All these kind of is parameterization, and the intent understanding is really important, because I'm asking something for a previous month and last week, right, and certain date. So these kind of things really important to improve your efficiency. And then there is a retrieval re-ranking, and then the bonus one is multi-stage retrieval. So if you talk about retailer re-ranking, so think about what you do is simply you go and do the vector search and return, let's say 20 documents, and try to list the top one to them. Rather than doing it, it will basically make your system, AI system, more efficient, because you try to build another model that will take that 20 response that is coming from the RAG, for let's say Pinecone or vector database, and then apply a prompt on top of it, and then return return the data. Let's say top 5 or top 3 or top 2, for example, and then return the response to the customer. So this is like, without re-ranking, it's many meek or irrelevant docs go to the LLM, and also it improves the input token inside the LLMs. So the more token use, lower, and more token use, yeah. In this way, we'll be using more tokens, and also lower answer quality, because we'll be using more tokens, we'll be sending irrelevant data, and it will be running irrelevant data. We'll be sending 20 more information. That is not good. If we use that re-ranking, like we try to build the agent, then only the most relevant docs are passed, fewer tokens used, and higher answer quality will be there, right? And these are the benefits, like higher precision, better actual factual accuracy, lower token usage, and more trustworthy answer. And then 15A is a multi-stage retrieval. If you see over here, so what happens is, the ranking pattern that we talked about, the search pattern we talked about, the semantic pattern we talked about, you can combine all of them together and build a multi-stage retrieval. And so let's say that you do keyword search, you do embedding search, you do, let's say, this whatever re-ranking, and then return to the customer. So if we talk about this is a broad search. Retrieve a large pool of candidate documents, let's say this, to avoid missing anything important, and then do the re-ranking. Build a re-ranker agent that gets the top 20 agent that we need. Let's say we are trying to build a best employee finding app, AI agent, and then expand. Look at the neighbors, related chunks of citation from top docs, and capture additional context, and then final context, and then return to the LLM. So this way we have covered around 16 different ways. If you like the video, put in the comment. I'll send another 15 one in the next video. Correct? And these are the different 8 layers that we will talk about. What happens is, layer 1 is basically trying what are different types of optimization is available. So the first one is input optimization. The second one is retrieval optimization. So input is whatever we are giving to LLM. Retrieval is whatever we are taking from, let's say, our RAG, our databases, or Elasticsearch, or let's say Pinecone. Memory optimization is how much kind of memory we are trying to save using context pruning that we talked about, or semantic memory that we talked about. Inference optimization is how better we can use different models together, like like semantic, like you can say model routing, or say cost aware routing, etc. Right? And there is agent optimization that we talked about. There is a parallel tool called retry logic, etc. Output optimization, I did not talk about output optimization, but the base part would be always make sure you take out the structure information rather than a just plain text, because that will always fail. You need to have a structure information, you need to have a schema settled, right? So that all the data that you need for your application or for your next AI agentic system, every data will be available to you in hand, right? And then there is a quality and safety, and there is human governance. Human governance I did not talk covered in this video. Basically it's all about always, let's say if there is a credit system or healthcare system, or let's say legal system, so there you have to involve a human inside the loop. But let's say that the AI is being to make us efficient, so why are you gonna send 500 pages document to him? You can send a summarized document and then tell them that these summarized document is coming from all those 500 data. So I just covered everything over here, and if you like this, tell me. I'll create another video that will have another 20 more better cost optimal techniques that I have personally used. Thank you.